integral of sine to the fifth x sine to the fifth x times cosine squared x dx. Cosine squared x dx. This is the case wherein at least one of the exponents is odd. So that when we solve this, we will now have to rewrite sine to the fifth x as follows. So for the solution, we have the integral of sine to the fifth x cosine squared x dx is equal to the integral of sine to the fourth x cosine squared x. The other exponent here will be rewritten as sine to the x, sine of x dx. And then we rewrite sine to the fourth x as you have 1 minus cosine squared x, you have squared cosine squared of x sine of x dx. This can be done because our sine squared x plus cosine squared x is equal to 1. That means to say your sine squared x is equal to 1 minus cosine squared x. And because we have sine to the fourth, your sine to the fourth is sine squared x raised to the second power. Okay, so we have this 1 minus cosine squared x raised to the second power. So from there, we can again simplify this 1 minus cosine squared x squared as you have 1 minus 2 cosine to cosine squared x plus cosine to the fourth x, cosine to the fourth x, and then you have cosine squared x sine x dx. And we can distribute this cosine squared x sine x dx to this one and come up with this time the integral of, so 1 times the entire thing here will give us cosine squared x sine x dx minus, when you multiply this again, this one along with this, 2 times the integral of cosine to the fourth x, because we have cosine squared times sine x dx, sine x dx plus, okay, can again multiply cosine to the fourth with that one with cosine squared x. We will have the integral of cosine to the 6 x sine x dx, sine x dx. And now if we let u be equal to cosine of x and our du equals negative sine of x dx, because if you remember, the derivative of cosine is negative sine. Then we now have the following, that is, from here, this is now this one is now equal to, you have 2 from cosine squared u will now become equal to u to the second power du. Okay, u to the second power du. That is, our u is cosine x, so that's u to the second power. Then we have du. Sine x is your du. But because we have a minus sine x, so that should give us negative. Here, negative. Then minus 2 cosine to the fourth x sine x dx. That should give us plus, okay, plus 2 times, okay, cosine to the fourth, so that is our u to the fourth, we have sine x, so that sine x, that is our du, okay, du. And then plus this time this one cosine to the 6, so that is supposed to be cosine x sine x dx. But because we have sine x dx here, and remember that our d is supposed to be negative sign, so this should be replaced by a minus. Okay, so we'll now have from here, this should be a minus here. Oops, I am supposed to make use of an eraser. So let me just make that one clean. My eraser is not working. Wait. So let me have that eraser here. Okay, there. So that's supposed to be a minus. That now becomes minus there. U to the 6 du. Okay, minus integral of u to the 6 du. Okay, so when we integrate that, that becomes negative u to the third, because we actually add up 1. We had yung ano, so make that one like to have that one clearer. So okay, and erase, ayan, 3. So that should be 3 there. Should be 3 all over. We have 3 plus 2u to the 5 over 5 minus, that should be u to the 7th all over 7 plus c. That is equal to negative, if we replace u by cosine x, negative cosine cube of x over 3 plus, that is 2 cosine of x, so cosine to the 5th x all over 5 minus, that is supposed to be cosine to the 7th of x over 7 plus c. And that would be the answer for the integral of sine to the fifth x cosine squared x dx.